Let me welcome everyone to this meeting of the virtual DB2 user group. I'm Trevor Eddles and I'm CEO of iTechEd Limited. We're a mainframe consultancy, analysis and technical authoring organization. And I've been chairing these user group meetings, the ones for KICS, IMS and now DB2, since 2007. And I've decided that it would be a good idea to share the hosting of the groups to introduce some fresh faces. So I'd like to welcome the first of these co-hosts, Amanda Hendley, who you may know from her time at Computer Measurement Group. So welcome, Amanda, and thank you for being here today.
Trevor, thanks for having me. I'm really excited for this session and to be a part of this user group. Before I walk through the agenda, I wanted to, we were going to do a poll today, and I'm hoping everyone can just throw in the comment section how they feel about the timing of our sessions today. So let me pull up the poll. So just real quick, if you would, take a moment in the comments, in the chat, to drop your time zone and time that you want to participate in these sessions in the future. We haven't done a check-in with everyone in quite a while to see what the best timing is. So I'm gonna hope we get a couple of responses in. But we're currently, I'm Eastern time zone, so I'm currently 11:30 Eastern. So I know we're in the afternoon, 4:30. So Ken, you're Pacific. Is this time good? Is basically the question we're asking. Are we at a good time block? Okay. Thank you, Marcus. Ken, I appreciate your input. Awesome. Well, you can keep dropping those. I know we just want to make sure that we're able to hit the right people. And I recognize too that we're asking the people that could make this time if they would like a different time. So welcome your input. If you've got any other thoughts on it, you can send those privately or in the chat, and we're just going to collect all your data on it. And now, before we launch into our session, I want to thank our sponsors, Enablement and Planet Mainframe. You can find out more about these sponsors on the user group webpage. So check them out. I know Enablement, I think, has a link to a special landing page for DB2. And I'm going to mention a resource for you later today. And then obviously Planet Mainframe, new partner, and a great resource for you with lots of articles and videos. So for today's session, we are going to take Q&A in the chat function during our presentation. Our presentation today will run less than an hour, so I think we'll be out of here well before 1 o'clock. But please do remember we're going to have Q&A at the end, so there'll be plenty of time for you to think of questions and pop them in there. And we are also going to record the session, and let's make sure we've got that going. We are recording our session. So the session video will be available to you on the website and on YouTube. And we'll also have the presentation for you as well. So with that, I think we're about ready to get started. I want to thank our speakers today. So we've got Tori and Keziah Knopp. And Tori is an Associate Technical Enablement Specialist on the IBM Z at Washington Systems Center. And she's part on the DB2 ZOS team. She analyzes client data, makes technical recommendations, delivers the DB2 REST and hybrid cloud workshop, and develops new workshop offerings. And Keziah is a DB2 for ZOS specialist, also at the Washington Systems Center. And prior to joining the WSC, She focused on Z Communications server, writing papers, and delivering presentations on IPv6 and IBM Z encryption readiness technology. She presents at SHARE conferences and other industry events, and is the author of Db2 13 for ZOS and more Redbook. Most recently, she worked as on a special project for Db2 subsystem automation, collaborating with the developers and writing Python scripts. So Tori, Keziah, we're so excited to have you here today. I'm going to make Keziah the presenter. All right,
Thank you so much, Amanda. Great. Let me see if I can share this. And put this in presentation mode. Okay, can you see my screen?
Click your swap displays button at the top.
Oh, is that what we're doing? Okay, let's see. How about this one?
Looks great.
Wonderful. Thank you so much for that introduction. As Amanda said, my name is Keziah Knopp, and I'm here presenting with Tori Felt. The material that we're going to be going through today is actually associated with the workshop that Amanda mentioned. We have a Db2 for ZOS REST and hybrid cloud workshop that we give. If you are interested in that, we are hosting in-person and virtual ones coming up, and we can give you the link to go and find what that looks like and all of those things. And I'm actually going to turn off my video so I can look at my monitor and save bandwidth here. Okay, so the material that we're going to be talking about today is about Db2 for ZOS and REST services, how both of those are related and how REST services are very important and significant in our daily lives when we're interacting with technology, and also really important when we're talking about mainframes. So that's kind of what we're going to start with today. And I have my own agenda slide. So when we're talking about Db2 for ZOS and REST services, I'm actually going to start at a high level talking about mobile trends and the API economy, because REST services are tied into RESTful APIs, and we're going to take a look at where we see those in technology, where we see those in mainframes, and how this could impact your day-to-day job potentially too. And then I'll go into RESTful APIs, an overview of those, what they are, how you can interact with them, because they're used to be a form of communication used for typically web and mobile applications. That's kind of the focus of what we're talking about with REST services and RESTful APIs, is being able to have access to web and mobile applications to send and receive information from them. And then I will go into Db2 for ZOS REST services, how those two are tied together and what that looks like when you're interacting with Db2. And then versioning is a newer feature of Db2 for ZOS REST services. And I'll actually walk through an example of an application and what that looks like using versioning that ties into Db2 and REST services. And then I will pass it off to Tori to talk about Db2 REST and ZOS Connect. Those two things kind of go hand in hand and tie into RESTful APIs and the rest of the things that we're talking about today. And like Amanda said, if you have any questions during this, feel free to pop it in the chat and I'll have Tori monitor it. And then when she's presenting, I will be monitoring the chat. And I think there's at least one question in here that we'll ask you to fill in and answer in the chat when we get there. There we go. So mobile trends and the API economy. This is subtitled, it's not justified, because we've seen a lot of web and mobile applications grow significantly over the last, especially 5 years, but 10, 20 years. All of this has grown in significance and relevancy across the board. And we're going to be talking about where we see these web and mobile applications and where we see APIs as well. So this chart highlights some major trends that we see in enterprises working with web and mobile applications. And I'll walk through a couple of these here. So for example, in the top left corner, we're talking about mobile trends. We're talking about the Internet of Things, IoT. These are machine-to-machine connections, and this has continued to increase in where we see this today. So my personal example is when I was living in a house, there was 4 of us in the house that I was living in, we had in smart homes. There was one in every room except for maybe the small bathroom, I believe. And that was just one thing that we noticed, that it was really easy to use and a lot more prevalent in our day-to-day lives. And right now I have my smart home hooked up to my smart lights because I would rather tell Google to turn off the lights than flip the light switch, for example. So this is just where we're seeing a lot more of these types of connections come into the world and society that we live in today. Moving to the top right corner of the screen box, mobile is primary. We've found that 91% of mobile users keep their devices within arm's reach 100% of the time. So that's in their daily lives. I know for me, I have a work phone and a personal phone, and they are within arm's reach throughout my entire day. I will set an alarm on my phone and wake up to it, and it will just be within reach basically the entire time. So that is also showing how relevant these features are in technology that we use on such a regular basis. And then in the bottom right corner, we have this orange box. And this is talking about location-based messages that we see with mobile data. So the one that pops up for me the most often is when I get to a new airport and I'll get the little message notification from Maps saying, welcome to SFO or DFW. Would you like to order food? Or would you like to go shopping? So my phone automatically knows where I am. They know that I'm traveling, that I've arrived at an airport. And this way they can send me notifications so I can find the things that I want or go shopping or order food. Then in the bottom central area, we have mobile. It's about transacting. This is talking about things like Cyber Monday or any online sales or deals. A lot of these special days or special holidays where a lot of folks are shopping in certain areas. We're using our phones and our laptops to order a lot of things online that we may have bought in person in the past, for example. And then finally, this one on the left is talking about creating a continuous brand experience. So we often have multiple devices, as we've already been talking about. So for example, if I am looking at booking a flight on my laptop and I'm logged into American Airlines, for example, and then I haven't bought it, but later in the day, I switch over to my phone and they're like, oh, would you like to confirm the flight that you were looking at? So having that continuous brand experiences between multiple different devices and screens like that. So moving right along, we're also talking about the API economy. So I know I just talked a lot about web and mobile applications and how we see that in the technology that we use. And behind the scenes, we have these API economies, we have these business APIs. And business APIs, I want to make a difference between the traditional technical APIs, which are there to provide some level of technical complexity to understand what's going on when we're talking about web and mobile applications. And business APIs are more specific. They're talking about driving a particular business objective, whether that is increasing revenue or extending customer reach, stimulating innovation. These are just some examples. Maybe designing an API that is fully for a product implementation. What APIs are going to be in use for a particular product? I'm sure it's going to be a lot of them, things like that. So we often see these business APIs that are based around what we can impact in the business that we're looking at. And so that's kind of what we're going to be talking about with APIs that are related to enterprises that we're talking about today in our discussions. And I know that I'm talking to a mainframe audience, so I want to pull that in as well. For when we're talking about web and mobile applications, we have a lot of people that think about the cloud. That is becoming more and more relevant and being in use today. And there's a lot of expectations that come with using the cloud. People want to be able to connect to it whenever they want. They want to be able to test things out, try things out without penalty when we're talking about a cloud solution here, and not be tied to any single solution. There's a lot of multi-cloud options out there, hybrid cloud options out there, multi-hybrid cloud. So being able to have access to all of those different types. And when people think about it, they want it to be familiar and standardized and easy to use so they know what to expect when they're accessing it. And some of those things may happen with the cloud. And we're over here talking about mainframes. And there's a lot of misconceptions that are associated with ZOS or with these systems. And I want to take a moment to acknowledge that. And I know for myself and a lot of people that work on mainframes, we recognize that these are just myths. They are misconceptions and they're not true. But things like Z does not support modern technologies, or it can take a really long time to enact change or to update things. Maybe the security policies seem foreign or complex or not easy to understand, or Z systems don't really integrate well with other technologies. We see these a lot, and that's something that we do have to combat when we're talking about mainframes. And we know that that's not necessarily the reality. The reality is with Z, we have a lot of these things that are shown here on the screen. We can use Python, which Amanda mentioned that I had just done. We can use Node.js, we can use Swift, we can use all these other languages. We have IBM API Connect and a handful of other connects that allow us to have access to use and develop APIs. We have IBM Explorer for ZOS. This is an Eclipse-based user interface that allows us to program code easily, no matter what type of code you're using, whether that might be Python or Node or Swift or SQL or JCL. And we have HTTP response classes. That's what's here on the bottom, and we're going to be talking about that in a few slides as well. And we can use Swagger documentation, that standardized form of looking at APIs and RESTful APIs here. So this just all goes to show that we do have these modern technologies on Z, and we are using them, and we have been updating and developing them going forward. And this is a chart that shows the growth in relying on APIs from a developer perspective. So we found this from stateofapis.com, and they did this survey of a lot of developers and programmers on, it was at the end of 2022, beginning of 2023, and they were talking about how many APIs did you use in the previous year in 2021, and how many did you use in 2022? There were a couple, like less than 5% or 5% about that were using less APIs. But a lot of developers were either using about the same, maybe a little over a fourth, and then almost 2/3 were using more APIs in 2022 than they did in 2021. So that is just showing the growth. And then this bottom chart here was showing what did they expect to in terms of relying on APIs in 2023, talking about this year and going into the future. And most developers said more, that they were planning to rely on even more APIs in 2023 than they did in 2022. So that's just showing you that the growth and significance of APIs is continuing, especially from a developer programmer perspective here. So I'll go into what are RESTful APIs. I've been talking about APIs already, and I want to briefly go into an overview. But before I do that, this is my one poll question. So I'll have you put your answers in the chat. Typically we will ask this in person when we're doing a workshop, or we usually use WebEx and they have a polling feature. But I do want to know who I'm talking to in the audience. So what is your level of experience with REST services? Maybe this is your first time hearing about them. Great, we'll go over it from that level. Maybe you're familiar with REST services, you've used them before, you've seen them. Maybe you know RESTful APIs. you've used APIs, you know RESTful APIs, that sort of area, or you know REST really well. Maybe you use it a lot, maybe you use REST services and RESTful APIs, you know the structure of it, things like that. And I'll give you a second to put your answers here in the chat. I think you can just put, okay. Yeah, you can select multiple, put a half answer, great. Thank you for putting these in. Okay, I see some ones, some twos, 1.5. Okay, thank you. Then I will keep that in mind going forward as we continue to talk about this. So what is a RESTful API? I will start here. So REST is an acronym that stands for Representational State Transfer. It is an architecture that is being used to send and receive information, generally when we're talking about these web and mobile applications, but it can be used for a number of different areas. And this type of architecture is stateless, meaning you do not have to keep track of what is being sent and received before or after. You just send it as it is, the current state, and nothing else. So you don't have to maintain a lot of different areas about where were we before, where are we going. This is just the current state. It also uses client-server relationships to send and receive this information. So we will have clients that can get access to information from a particular server. The server will be passing down information to a number of clients. So that's the setup structure when we're sending and receiving information. And overall, it uses a cacheable communications protocol. The protocol that's being used is actually HTTP, Hypertext Transfer Protocol. And this is what we use when we're talking about the internet and the World Wide Web. Amanda mentioned I have worked on the ZOS Com server in IPv6. So if you have any questions about HTTP or the World Wide Web, let me know. I love to talk about that. But a RESTful API, where an API is an application programming interface. So it's an interface that we can use when we are programming an application to have access to certain functions or types of information that we want to send and receive. And that API will use HTTP requests to get, put, post, and delete data. Those are some keywords that we'll be looking at. And there are a few more keywords that are associated as well, and we'll talk about them a little bit. And one quick note that I have is that we're here to talk about Db2, as Tori and I are Db2 specialists. Db2 native REST only supports the post method. So when we're talking about those HTTP requests, we have get, put, post, and delete. And Db2 works only with post. Their Git can be used for some system-related functions, but really the ZOS Connect API editor allows you to reassign post to a different method, and that technology will be able to will allow you to use all of the methods that are associated with HTTP requests. And this is why we call Db2 native REST REST, and why ZOS Connect, let's say, is RESTful. So REST uses one aspect of this particular architecture and of these HTTP requests. And RESTful means you have access to use the full capabilities of HTTP requests and everything that comes with being RESTful. So some key principles of REST. So this is how we are using REST services. We have our methods that's shown here on the left of get, post, put, and delete, the ones that I just mentioned. These are generally associated with HTTP verbs to create, read, update, and delete. The acronym is CRUD if you've seen that before. Those are relatively self-explanatory, and we'll go into more detail. But you will pair one of these methods with a particular URI, where URI is a uniform resource identifier, very similar to a URL, your uniform resource locator that you may use to access a web page, for example. And there are these different parts of a URI. We have a host and port. That is where we're going to access the information that we're looking for. And we will specify a certain path and parameter for, okay, where, now that we're at this location, where exactly are we going? And then what kind of details are we looking for? So those are those query parameters that are highlighted in that magenta pink value at the end of a URI. So for example, for a REST request, we may be looking for personal details using a GET. So we're trying to get information from a particular location. In this example, the host and port is acme.com. And we are looking at customer number 12345, and we want to get their personal information, let's say. So that is going to be our request. That is part of REST. And hopefully we will get a positive response back looking with the information that we're looking for. So in this example, this information, we're getting the personal details of the customer that we're looking for here. And this shows up in these name value pair formats. So really easy to read. We're like, okay, this is the information we're looking for, and we have it right here. And these formats are known as REST and as JSON. So this is the interface and the data payload format when we're talking about REST requests and we're sending and receiving that information. So REST, as we mentioned, is that representational state transfer. That's being able to use a URI in addition to those HTTP verbs. So in this example, we are updating an account. The account is located at myhost.com. So the application knows what to do based off of the URI that we're sending it and the verb that's associated. And then we have JSON. This is JavaScript object notation. And these are these name value pair formats that the data is then presented in. So the application will return the data and it will be presented in these name value pair formats, which is pretty easy to read and understand. I'm looking at account 12345. The account name is Smith, and we want to update the account. We want to deposit $1,000 into the account. So that means that account value will be updated. It will be changed. And that's kind of this example that we can walk through here. So for further examples of HTTP requests, in this example, we'll be looking at myhost.com at particular customer 235. So that's that URL at the top. And if we want to use GET, or if we're looking at a particular record, customer number 235, we will select that particular record that we're talking about. So if we pair GET with that URI, that means we're essentially just selecting that record. We're getting the information there. And this can be paired with these SQL terms. So that will be associated with select. If we want to update a record, that means we'll be using put as that keyword for the HTTP, and we'll be including info in that as well, information. Like on the previous slide where we were updating Smith's account with $1,000, in this example, we are updating the record for customer number 235, let's say. Post, this is used for creating a new record. So if we have a new customer that shows up to our business and we want to create a new record for them, then we will be posting information. And this is paired with a SQL term insert. So we're inserting a new record for customer number 235 here. And then finally, delete, pretty self-explanatory. If we pair delete with that URL, then we are deleting customer number 235. And again, here is that same note that DB2 native REST only uses post. So it will use post, that post method, and we pair that with any of these SQL statements that are associated with the other functions. So for example, if I'm in DB2 and using native REST, and I would like to delete customer number 235, I would actually post a delete for customer number 235. And that's that difference between DB2 and then when Tori talks about US Connect a little later on, we'll have that full functionality available there. So why is REST so popular? At the beginning, I was talking about how all of these web and mobile applications are increasing in significance and relevancy. They're growing. A lot more developers and programmers are using APIs, for example. Why is this happening? So one of the reasons is it is built on an ubiquitous foundation. That is that HTTP that I've already mentioned that's being used when we access the internet. So that is something that is broadly available to anyone who's using the internet for sending and receiving information, for accessing their technology. So it's really easy to kind of plug into that since it's already there and existing. Increasingly common. So this kind of helps itself, right? If I am at my own company and I am looking to send or receive information from a different company or a different location, and I know that they are using REST services or RESTful APIs, then it'll be a lot easier for me to use REST services or RESTful APIs because I know that the format is going to be standardized. I know that I'm probably going to get it with these HTTP requests and in JSON. So I'll be able to have that same format for sending and receiving that information if I'm accessing data from somewhere else. So being increasingly common makes more and more people want to also be on that same level. Stateless, I mentioned this before. That means that there's actually less overhead associated with REST as opposed to other types of protocols such as SOAP or WSDL, if you're familiar with either of those. Since REST is stateless, it's a lot less overhead and you don't have to maintain other information that you would have to when we're talking about things that are prior to what the current state is. You don't have to maintain any of that. It's also relatively lightweight. Similarly to stateless, it doesn't have all of the other extra things that kind of go with it. It's pretty easy to use and it's relatively easy for development. So those name value pair formats in JSON, for example, pretty easy to read, pretty easy to pick up, regardless of what your experience level is. Maybe you have not a lot of experience programming, or maybe you have a lot of experience programming in something totally different. But either way, it's pretty easy to use, especially since we're so familiar with the internet right now and we're very familiar with accessing a URL. Here we go. So now I'll move into DB2 for ZOS REST services, and a more technical overview when we're talking about both DB2 and REST. I'll check the chat here too. If there are any questions, please let me know. Okay, so there's a set of objectives when we're talking about DB2 for ZOS REST. And these objectives are pairing DB2 with REST. And the first one is being able to use REST and JSON to invoke one SQL statement or stored procedure. So we'll talk about what that looks like when we're talking about one of those, but we'll be invoking a SQL statement or a stored procedure using REST and JSON there. And this allows you to enable new business value for your enterprise data. Since a lot of these companies are using REST services and RESTful APIs, then you have a lot more access to a wider variety of where your data can be sent and received within that standardized format. I mean, you can send and receive it, but it will be in this particular format and enable business value in a new way. And it's modernizing using the power of SQL or SQL, whichever one you prefer, that structured query language that we're using with databases. So that will allow you to modernize continuing to use SQL here and fully unleashing your DB2 data for the API economy. So how does this all happen? So DB2 has a set of properties that I'll walk through on this slide. To invoke a DB2 REST service, that is direct DB2 for DDF REST access. So that's your distributed data facility that's inside of DB2. There's direct access to that when we're talking about invoking a REST service. There's a simple architecture diagram coming up. And the service details. So when we're talking about a REST service for DB2, a REST service will include either one SQL statement that we kind of talked about before, what SQL statement do we want, or a stored procedure. One of those will be permitted per service. And a service is this statically bound package in DB2. As opposed to a dynamically bound one, it is static, meaning we have determined how to access it. Instead of changing a few things at runtime, it will already be statically bound. And then you can also use call, delete, insert, select, truncate, update, and width. So those are a few of those other key words that are available. Merge is another word that can be used in certain other areas of HTTP requests. And for DB2, merge can be used in a stored procedure, but not just a single SQL statement because you have to include more information there. And then finally, all of the DB2 based SQL data types are available for being used in REST services. And this includes a binary large object, a character large object, a double byte character large object, and XML files. So a lot of these things that may be familiar when we're talking about DB2 and SQL are available within DB2 REST services. And that's something that we wanted to keep. So here is a relatively simple architecture diagram for accessing the distributed data facility inside of DB2 for COS. So before REST, we would use things like JDBC, Java Database Connectivity, ODBC, Open Database Connectivity, or .NET. So any of those particular protocols or standardizations can be used to access data inside of DB2 through a particular port number. And once we're inside of DDF, then that data will be parsed using DRDA, that direct relational database architecture. And now with REST, we have our mobile application where we have that JSON data, those name value pair formats. And we're going to be using native REST through the exact same port number that you were using before. And then we will access the distributed data facility inside of DB2. And once we're in there, we'll parse the data using JSON and HTTPS. And once we're in DB2, all of the normal actions that you can do on your data are there, such as authorization checks, thread creation, and a SQL execution. So now we'll talk about how a developer can go and retrieve data when we're using REST services. And I will talk about two different personas here. We have Max, our mobile app developer, and we have Devin, our DBA or DB2 app developer. And I recognize that in some companies, these may be the same person. Your mobile app developer may also be working on DB2 applications or be a DBA. And in other companies, there are a number of different people that embody these two different personas. But we'll start by talking about Max, the mobile app developer. So this persona can invoke a DB2 REST service. Again, REST service consists of that store procedure or SQL statement. And then the output will be returned in JSON format. And the mobile app developer does not need to know SQL necessarily, nor that the data came from DB2. They're just looking at that output in JSON and calling the REST service. And then we have our DBA or our DB2 app developer. And Devin will be creating a DB2 REST service. Again, that consists of a store procedure or SQL statement, or they can create or reuse the store procedure or the SQL statement in the REST call. And they don't necessarily need to know JSON. So they're the ones that will be creating the REST service. They'll be looking at DB2 and saying, hey, what do we want to call on this? And actually doing that creation. And there are a few different ways that we can manage DB2 REST services. One is through a REST client in browser. If you come to our workshop, you can view this and the REST application. The REST application is very similar to the browser in terms of look and feel as an interface. And that's kind of navigating around, or you can use the bind subcommand. If you are familiar and prefer standard DB2 interactions, that is fully available as well to manage DB2 REST services. So here's kind of an overview of looking at the progression of REST services when we're talking about a mobile app developer and a DBA or a DB2 app developer. So for the life of a service, we can discover a service that already exists, or we can create one. And then we can display the service, we can view it, we can execute or invoke the service. And then finally, if we no longer want to use the service or we don't want it, we can delete the service. So this is kind of a life cycle of a REST service in DB2, paired with those personas of who can do what in terms of these capabilities. So when we're talking about discovering a service with DB2 REST, you must have the authority to access the services that are available to call execution or ownership. This is usually sysadmin or syscontrol authority or a sysdba database administrator here. And to discover the services that we have, we will either issue a post, that's that HTTP request right there with a particular URI, and in DB2 we'll be calling DB2 service discover. So that's when we're using DB2 native REST. You can also call get on the services that are available, and that's something that's here too. And that will display, or that will show all the services that are available that you can kind of browse through there. And you can also use that URL at a particular host and port location and looking at services. And assuming all of this goes well, you should get a successful completion code of 201. This is a REST status code. This is an HTTP code, not DB2, but you'll either post or get looking for those services and get a successful completion code of 201 when you are looking at those. So now creating, again, you have to have the appropriate authorization to do this. And this will be Devin, the DBA or DB2 app developer, and those authorizations can be set. And to create a service, that will be post. So you're creating a new service and you're posting to the DB2 service manager, and you can specify what you want to see in that particular service. Here in this example, we have create service. We've specified a SQL statement, the collection ID, the service name, a description of it, and the bind option. So those are those DB2 features that we will be using to create that service here. And again, we should get that successful completion code of 201 saying, hey, you've created your service. Great job. And here's another way to create a service. This is what it looks like when we're creating a service using JCL. This is actually using that bind service subcommand in DB2. And this is kind of what that looks like. This is the interface of the Eclipse-based user interface. And you can also do it in an ISPF TSO interface if you'd like. But here we've shown that you can specify the exact same things that we were talking about before. So we've got our bind service, our name, the description, all of the features are included as well. So if that's the way that you prefer to create a service, let's say, you can do that using JCL. And assuming this goes well, you will get that JCL completion code of 000, meaning everything is copacetic. So for the last three, I won't go into detail. You can find them at this link when you get the slides in the IBM documentation. They're very similar to the ones that we just looked at for displaying a service, executing it, and deleting it. So here we have troubleshooting REST services. So let's say you get something other than that successful completion code of 201. What does that mean? And again, this is relevant if you come to our lab or if you do end up using these. So if you get a 100 level, for example, that's just informational. That's usually pretty fine. We have our 200 level success. Our 300 level is a redirect. That means that the client and the client server relationship will have to take some action. Or 400 level is client error. So if you've ever tried to go to a web page, for example, and you get 404 not found, that's the same thing that we're talking about right here. 500 level is not great. That means there's something wrong with the server that needs to be addressed. But these are the different levels of those return codes that I was mentioning. And if you click on the link, then you'll get a lot more details on each of those codes. And I will move into versioning. So versioning of DB2 REST services came as an APAR in the last couple of years, maybe 2 years ago. It was during COVID, so it couldn't have been that long ago. And versions of REST services allow for the development and deployment of new versions of REST services while existing versions are still being used. So if we have a REST service, we'd like to create a new version of it, we can do that pretty easily while the existing versions are still being used. It's built on existing package versioning support. It's already there. You will be using the same authorizations for creating those as you would have been previously, such as those DBA authorizations or mobile app authorizations. And then you can specify a version ID. So what version are we looking at? The default is V1, but you could name it anything that you wanted to if you wanted a version of a service named Fred, for example. And then you also now have the ability to select the default version. So if you have a REST service and you create a new version of it, okay, now I feel version a default. So it will be called every time that's there. So here is the URI format when we're talking about versioning. The original is what's shown here on the top. We would specify services and the service name, the collection ID is in brackets because that's optional. So in this example, we're looking at sys IBM services and calling display employee. And then you can specify. So now I'll walk through a little overview of what this looks like for an application. Let's say we have a mobile application that employees of a certain company can use to view other employees in the company. I know that we have that at IBM. So we've created this service to display employee. And then let's say we enable versioning after we've created that first service. And now we're actually going to create a new service. We're going to select by employee number. And this is going to be version 1. So now we are displaying the employee name and the employee number. And let's say I want to know who Christine Haas, who their manager is. That might also be something that I want to include in the select by employee number service. So instead of creating a whole new service, select by employee number with manager, I'm just going to create select by employee num version 2. And here's the SQL for that that's shown. And now we can display the employee and their employee manager. And now let's say Christine is doing a great job and I want to call their manager and tell them that. Let's say I want to have the manager phone number included in this application. That can be something else that I want to add in. And instead of creating a new service that says select by employee number with manager and manager's phone number, for example, I can just create version 3 of select by employee number. So this simplifies this development of particular REST services that you're looking at. And now we have the manager phone number that's also in the application. So I can call the manager and say, hey, Christine's been doing a great job. So glad that we've been able to update the REST service versions, and now we're on version 3. So for REST service versioning, it can be enabled by applying the associated APAR, this PI 98649, and then you run the sample job DSN JR2, and then you'll have the ability to use versioning with your REST services. I do include a note here that if you remove the APAR, that the entire Db2 REST service functionality will be unavailable. I wouldn't have to put this note in here if we didn't have people do that. So if you are using REST services and you apply versioning, just let it be. So to recap on versioning features, there is no impact to pre-existing versionless REST services. So if you've created a service and then you enable versioning and you create a new one, all the other ones stay the same, that's fine. There's an empty string value actually in the version ID field for those versionless services that were already existing before you've enabled versioning. However, after versioning has been enabled, these services will always be versioned. So if that's that V1, that V2, or whatever you'd like to specify it to be. And overall, versioning simplifies the modification of services. This makes it faster to develop these services, more easy to use, improving your time to market overall. So now, what if I want to use all of the REST methods and not just post, as we've been talking about in DB2? And I'm going to now pass this off to Tori to talk about both DB2 REST and ZOS Connect.
All right. Well, great question. So with, if we want to use all of those methods, the get, put, post, and delete, this is where ZOS Connect comes in. And DB2 REST and ZOS Connect are really perfectly paired. So in the next couple of slides, we'll transition into Connect, and I'll go over how it can add value on top of your DB2 native REST services that Keziah took you through. And we'll see how DB2 and Connect is paired. All right, and going into DB2 REST services with ZOS Connect, if you could go to the next slide, please. Oh, Keziah, can you hear me? I don't know if she lost audio. If I don't have sharing privileges. Keziah, are you there? Oh, she may have lost her connection. Let's see here. Are you able to grant me sharing privileges?
It looks like Andrew has host privileges back. If Andrew, if you could share or grant those privileges to Victoria.
Thank you.
Okay, thank you.
Yeah, I just got a message from Keziah. She lost her connection. Oh, great. Okay, let me go to my slide real quick. I got the privileges. All right, desktop. Let's see.
And I have the PDF if
Okay, yes,
share it.
if possible, because it's having me quit Zoom for some reason and log back in if I want to share.
Will you give me permission?
Do I have to do that?
Yes. Just
Okay. And how
give
do I
me
do
that. I believe the 3 dots next to my image.
I think I can do it. I'll take care of it.
Okay.
Oh, okay. Thank you so much.
No problem at all.
Awesome. Okay.
Okay.
I believe this is the slide you
Yes.
wanted.
Perfect.
Yes.
Thank you so much.
I just got back in. So sorry about that. I completely lost connection. Do you want me to pull it up, Tori, or do you want to go from here?
I think Amanda's got it. This should work.
Okay.
Thank you, though. Okay, so going into DB2 REST services with ZOS Connect. So when we have native REST, that's everything that Keziah was going over. It's a good way to expose DB2 data. However, with these native REST services, you're really only able to use the post method, and you're kind of limited on what security protocols it supports. But with the RESTful API model, mobile and cloud programmers are able to use more methods such as the get, put, and delete along with that post method that we talked about. So for example, if you want to do an update, you can use the put verb. And with ZOS Connect, you can use appropriate methods and more industry standard models to implement those RESTful APIs. And going into a little bit of an architecture overview here. So earlier, Keziah had a version of this chart where we had DDF access, which is how we connect to DB2 before ZOS Connect using JDBC, ODBC, or .NET, and then using the native REST services with HTTPS and JSON parsing over there on the right under DDF. But if we see here, introducing ZOS Connect in the middle, your mobile apps or the cloud apps can use ZOS Connect using all various methods, put, post, delete, get, and ZOS Connect will basically drive the same REST service and get the data back out through ZOS Connect. So the overall idea here is basically adding the value of supporting all the methods and verbs, and really just having a consistent, uniform configuration for accessing the data on the mainframe. Okay. Now, looking from a developer's point of view, let's see what this means with ZOS Connect compared to our native REST services. So on the top here, we have a Db2 native REST service, which is supporting the post method. We have the URI and the service sys IBM service, and we're selecting by department stored procedure. In the body, we see our schema using the which query, and we basically want information on department A00. However, if you're using ZOS Connect, you see on the bottom example here that you can now use the get method. So we're using port 9446, which is the port ZOS Connect accesses. And now using this Connect port, we're not using Db2 port. So we're using the same URI as the top example, but you can have a unique API name, such as employee, and you can select by department number A00, for example. So overall, to a developer, this is much more meaningful and straightforward on how you can create these APIs and what you want to do, basically. Okay, so to kind of recap here, we have the Db2 native REST service above the dotted line. And basically, we have to create a Db2 REST service by issuing the post method and using a REST client SQL statement or batch job, and then using the Db2 address space to create this API here. But once that's created, below the dotted line, we can basically go into ZOS Connect using an API toolkit and import that service that is already created. And then you can basically keep building services in order to build and keep building services and importing them in order to build your API. And once you receive the PDF version of this, you'll be able to click onto these websites and get more information here as well. Okay. Going into a high-level overview of ZOS Connect. So basically, there are two main components: the runtime server. So first, this is running on ZOS, and it's going to process all of the API requests as they come in. So it will do security checking as well, and basically will take JSON request data, which is what we saw when Keziah was going through the JSON name value pairs request information. And it will put in a URI, and based on the APIs that it has, it basically will determine what backend systems it needs to connect to. Once it's connected to those backend systems, it will come back and have a response, and ZOS Connect can map that response to the API. And then on the bottom here, we see something called tooling platform, which is Eclipse based. And basically it's a graphical point and click tooling, and it defines APIs to do mapping for our JSON. And basically, as you build an API, this tooling platform will create the API document, usually our Swagger document that Keziah briefly went over in the first part of this presentation. And it basically describes the API, inputs, outputs, methods you're using, get, put, post, or delete. And you can use this open source tooling to basically try out APIs that you are creating. So that's kind of part of what makes this so attractive to developers as well. Okay, so one of the core functions of ZOS Connect here is that it uses mapping for RESTful APIs, basically mapping to back-end services. And we see ZOS Connect server in the orange box. It runs as a started task in the ZOS LPAR. And as I said, the majority of the work that it does is mapping. And if we go on to the next slide, we can take a closer look at mapping here. If you see below here in the purple, we have an example where we want to get information from acme.com for customer 12345. So we have the URI, the name of the API, and basically this request can come into ZOS Connect and basically says, okay, I know the customer API and I want to map the path parameter to the ID field. It can be a KICS example or DB2, but basically ZOS Connect will drive that DB2 program and the program returns some data elements. ZOS Connect will then map and go into the JSON format and send the response back to the application that is requesting the data information. And again, this whole idea is around mapping. And it's also good to know that ZOS Connect is written in Java. So this is what being written in Java allows this to be written on zip engines. So this is not as big of a cost. It's a lot cheaper to run on zips. So that's a good feature here. And also one thing to note, as we're developing these APIs, the back-end applications remain unchanged. And you're overall creating a developer-friendly API for someone who may not know all about ZOS itself. ZOS Connect exposes ZOS resources to the cloud through RESTful APIs. Overall, we want a single point of entry to ZOS assets. We want to be able to access all this data on ZOS on the mainframe. And you can think of ZOS Connect as an API gateway to all of your backend subsystems. As you see here, KICS, IMS, DB2, MQ, and so on. And you can use other solutions from IBM, other vendors, and overall get to different types of backend subsystems using ZOS Connect. ZOS Connect provides a single configuration administration, a single security administration. So here is a single connection to access data from the outside world, basically. And it uses sophisticated tooling and mapping to map the JSON APIs to backend subsystems in a way that developers will be able to understand without having to write code for those backend subsystems. Okay, so in the next two slides here, I'll just give a couple of examples here of when customers have used this. First is a large US manufacturer that made use of DB2 native REST services to make it easier to access DB2 on ZOS. They had a number of developers that were not at all familiar with ZOS, but they did need to access that DB2 data. So what they did was they made services around the DB2 environment. They built a web page for a user interface so that developers could use that user interface to easily access the DB2 data without knowing ZOS itself. And overall, this helped speed up their application development time. And then the next example that we have is a large automotive company. So this kind of happened during COVID, this issue that they ran into. So their process to grant loan extensions was a manual process. And COVID hit, a lot of people weren't working, so they really needed to request extensions on their loans. Well, the company was getting so backed up with so many requests for their loan extensions. Overall, they decided that they needed automation and they wanted to automate this process. So they decided to use ZOS Connect to get and expose the mainframe components that are needed for the loan extension process. So all that data that was on the mainframe for their loan extensions. But by doing this, they took the loan extension process, which is a long process, many steps, and basically digitized it to be able to grant loans more quickly to these customers that are requesting their loan extensions. And overall, this led to a very high customer satisfaction. And that is just two ways that customers have used native REST services and ZOS Connect in their DB2 environments. Okay, and that brings me to the end of our presentation today. Thank you everyone for attending, and you will be able to receive this PDF, so you can click on those links, various links throughout the presentation, and find out more information. But I wanted to ask here if anyone had any questions at all. I know I don't see any in the chat, but if anyone has any, feel free to come off mute, or if you want to put in the chat, that's fine too.
I had one actually. I wondered if you could talk a little bit about if there's any performance impact on having a large number of users calling on DB with all of these APIs.
Yeah, thanks, Amanda. Do you mean like calling on a particular location, or like users who are accessing the information from a developer perspective?
Probably the latter. So if you open it up, like your example, are you going to have an impact on the performance overall?
The performance will be very minimal if for users accessing information. If anything, it would be when they're trying to change something or update it. And you have multiple people who are trying to do that, especially at the same time. That would be more tricky, but just getting the information will be not a problem at all.
Awesome. Thank you. If anyone has any questions, yeah, you can drop them in the chat. Or if you do want to come off mute, let us know. And could you talk about the any security implications of this? I mean, it's amazing because you're giving, like, to your point, you're giving a lot of people access to data that they may not have, if they're not familiar with mainframe, they might not have had access to. But can you talk a little bit about the security implications?
Yeah, that's actually a great question. And the security is a little bit different when we're talking about DB2 native REST and when we're talking about ZOS Connect and RESTful APIs, because on DB2, the security that we would enact would be either DB2 security or RACF for the particular users and authorizations. However, on ZOS Connect, there's a lot more security options that are available to be used and paired with anything that you're accessing with REST services or RESTful services. And that can be anywhere from, I mean, it's also accessing the web. So HTTLS, for example, that's being used, or forms of basic level of security. And then they have higher layers of security in terms of authorization. We actually do have a slide on security on ZOS Connect in our full presentation, or we can send you the appendix of that. And there's a lot more options that are available.
Awesome. Well, great. Well, Keziah, Tori, thank you so much for presenting for us today. And I think that everyone here learned a lot. I know I did. And maybe we've elevated everyone from that 0 to 1 level up into 2.5. So thank you for joining us. And we will have the deck and the video and everything posted online in a few days for you.
Great. Thank you so much, Amanda.
Thank you so much.
Thank you. And I've got a couple things before we go today. So we have for you a couple of articles. Todd Habekost has, on the IntelliMagic blog, has done another one of his cost savings posts. So you can check that out. And for your convenience, I've done a bit.ly, but also QR code. So if you want to take a picture of that code to head over and check out that blog and read later. And then we also have a video. So if you missed the March session from Chad Reibers, so that is posted, that video is up for you to check out as well. And again, it's also on the DB2 landing page. And then I want to bring your attention to our next session. So save the date on your calendars on July 18th. We'll be meeting. We have local applications can take advantage of system profile monitoring in Db2 13 for ZOS. And that registration is open and available at that link if you want to go ahead and register and add it to your calendars. With that, I want to encourage you to connect with the user group on LinkedIn, Twitter, Facebook. You can always use the virtual DB2 hashtag. If you've got any comments, Magic and Planet Mainframe for being a sponsor. If you have, if you know of any companies that should be involved, or any individuals who should be speaking for this user group, please drop us a line and let us know. You can find me at ahenley@planetmainframe.com as an email address to drop information. And lastly, I want to thank you for being a part of the community, and I look forward to seeing everyone in a month or 2 months. Thank you.
Thanks, Amanda.
Bye.
Thanks, Amanda.